linked list is considered as linear data structure, and it is designed to overcome certain limitations of array. And now let us have a look what are the limitations of array. The first limitation, space wastage. This is actually the primary concern of designing a linked list, to get rid of the array or get rid of the issues of array. So let me start with the first one. So as I have told you that linked list is designed to overcome certain limitations of array. So what are these limitations? The first limitation, it is said that the first limitation of array leads to wastage of space. But how? Well, let us take an example to understand this statement. In case of array, when we declare an array, any array, we must have to specify the bound or how many elements can be stored in that array. Let us take an example of integer array. This maximum number of elements in the array need to be specified at the very beginning. What the programmer does normally, we always go for a safer side. If we do not know how many elements will be there, we make it a big number. Normally 100, but most of the time it gives as 1000. Whenever we run the program, it will certainly reserve that 100 locations in the main memory. Once main memory is allocated to an array, that is being occupied. No other process can use that. But while testing the program or running the program to see the output, what it will do, certainly it will enter only few elements, very few elements, maybe 20 or sometimes maybe 10 elements. So if I enter only 10 elements in the 1000 size array, that means 1000 minus 10, which is equals to 990 multiplied by 4. That many number of bytes are wasted. These are not used, right? So what we do, this is considered as a problem, because this, whenever we have an array, we will waste certain space. If I write, say, instead of 1000, if I write, say, only 10, then certainly user may enter more than 10 elements. There is a possibility that user types 10 numbers, then more than 10 numbers, it exceeds the upper limit of the array, so it will give you data overflow. So data overflow, that to avoid that, we give a maximum value to the boundary. So that's the problem. So if instead of that, if this array is declared as not as an array, rather we want to declare it as a element in the linked list, what happens here in the element of in the linked list? In the linked list, what we do, we do not allocate space. We do not allocate space at the time of compilation. This one we allocate space at the time of compilation. That is why it is called static memory allocation. Here we allocate space at the time of executing the code. It is called dynamic allocation. Dynamic allocation of memory or dynamic allocation of space. suppose this integer, I want to store integer only, but this time I don't want to use array. I will be using a linked list. Linked list means it will create a space. Suppose user have typed one data, integer value 6, this 6, it will take 6 and it will also create a link to the next element. Initially there is no next element, that's why this field will be null. Then when next value will come, next data will come, say 16, then this element will be linked to the next element. This is the first element, this will be linked to the second element. Now this is similar to this array to store data. First element is 6, second element is 16, third element is 20. But here what it will do, it will take next element if it is entered by the user, and this element will be pointing to this. So sequence will be 6, 6, 16 and 20. This is exactly the same that we store it in the array. So end user will not feel any difference. Only the programmer do understand that the technique used to store data is different. And here the reason behind is, if the user enters, no matter if user enters 5, user enters 1, user enters 1000, there is no question of data overflow. There is no question of wastage of space if we use linked list. And in the linked list we keep the data not in a contiguous. If you remember, in array elements are stored in contiguous memory locations, and it is identified by a common name. But however, in case of linked list, the elements are stored in a scattered location. Elements are stored in a scattered location, and we have a common name. That common name is nothing but the pointer to the first element. If this is a pointer, of course the address we store it in one variable. We store this, and the element of the second address of the second element in the list will be stored here. This is, suppose the second element is stored, this is 6, second element is stored here, third element is stored here, say this is 300, then this 300 will be stored in this place. It seems to be pointing to this, and there is no more element, right? We have a common name, say A. In linked list we have also a common name, but that is not necessarily a common name. This is, we have the address of the first element. This is a pointer, say P, and all other elements are linked. And this link says who will be the second element or next element of the list. So in linked list, every element holds the address, the next element. So say this is 100, this is say 400, this is 200, this is 9000, right? This 200 will come here, 200, this 9000 will come here, and this is no more element, null. But here if it is 400, then next one will be 404, next one will be 408, next one will be 410, then there is no more element. So it is said that it stores data in contiguous memory location. Apart from that, what we can do, I have also indexed to these variables 0, 1, 2, 3. In case of array, if I want to read an element randomly, we can simply write a, then index number 2, a2. A2 is 20. If I want to access 20, then I cannot read this element directly. Means random access in linked list is not possible. Why? Because we have to traverse the entire list till we found the element, and this process where I have to traverse through each of the element is called sequential access. Sequential access. So in short, array allows random access, but linked list does not allow random access. Okay, elements in the linked list must be accessed sequentially. So this is considered as advantage of array over linked list. Let us check another point. Suppose that I want to add an element in this location. What I need to do, I need to shift, provided I have sufficient space, I have to shift 25 here, I have to shift 20 here, then the new element to be inserted in this place. This is the new element, say 15. I need to store the new element in this location. So shifting of element is necessary. Shifting of element is necessary. If I consider the linked list, I want to insert 17. I want to insert 17 here. 17. Initially, it is not pointing to anywhere. What I need to do, I need to place this pointer here. Let us suppose that this is 12,000. So I need to put this 12,000 here in this place, and I need to place 9,000 here. 9,000 here. So it will look like pointing to this. No movement of elements are required. But however, the problem is, if I want to put this pointer here, then I need a temporary pointer here. I need a temporary pointer at this place. Then only it is possible. Or at least I should have one pointer here. At least I should have one pointer here. Then only I can add this element. So in order to get a pointer here, I have to read all the elements sequentially. I cannot jump directly to this one. Without going into the programming complexity, it seems that it is easier to add in array. But is it really true? This is questionable. I said that wastage of space is less in case of array. Let me check that. Is it true? Okay, suppose that I have an array of 10 elements, right? I have an element, these are elements 2, 3, 4, these are the elements, but I have entered only 5 elements. So 5 locations are wasted, which is equals to multiplied by 4 equals to 20 bytes. And I have 5 elements, say 6, 9, 10, 11, 12. These are 5 elements. So I need 5 elements in the linked list. I'm comparing the space occupied like this, 5 elements. This is one more. and this is connected to this, this is connected to this, this is connected to this, and this is connected to this. Now it has two components. If you understand if you understand the concept of a structure, actually this comprises of heterogeneous data. This is integer and this is a pointer. If this is a pointer, it certainly takes minimum of 6 bytes, then maybe more than that, plus this integer is equals to 4 bytes, which is equals to 10 bytes, because this is integer type data, I'm assuming. So 10 bytes, 10 multiplied by 5, 50 bytes. I'm occupying 50 bytes here, and I'm occupying how many bytes here? 10 multiplied by 4, 40 bytes, right? Is it really, are we saving space here using linked list? Not necessarily. Not necessarily. So when the amount of data is very less, maybe 100 data only we need to store, we should not go for linked list. Why? It has lot of other disadvantages, like we have it complicated in terms of number of statements to be written, complexity of the program, lack of random access in linked list. So that is why, based on the problem, we need to decide, basically based on the size of data or nature of data, we need to decide whether we should go for a linked list or we should go for a array. When we compare linked list, one more thing we have to keep it in mind. In case of operating system, what operating system does, suppose that this is in a computer. Normally in a computer, more than one process are resided in the main memory. So that is why a program, suppose that I am running 10 programs at a time in the computer. It is true, and it is possible to run more than one program at a time. So every program, say this is memory space allocated to P1, this is the memory space allocated to P2, and this is the space allocated to P3. Suppose that these are memory locations allocated to the program. This is the main program, main memory, right? This is the main memory. And this program can hold only, say, 1000 lines. But your P1 program size is 2000 lines. So this 2000 lines cannot be accommodated at the same time in the main memory. That is why the operating system will divide your program into two parts. And one part, which is currently we are executing, P1.1 say, will bring to the main memory from the secondary memory. This is secondary memory, means your hard disk. Normally we store our programs in the hard disk. And when this portion will be over, it will replace the second part with the first part. So this part, P1 first part, will be allocated. The first part will be put back to the main memory, and second part will be loaded. This is called page swapping, right? Page swapping. Now, if I use a linked list, or suppose that if I use an array, I am executing the first part of the program and data is located here. Since all the data are stored contiguously, this data will be copied in this location. That means all the data we have together. Correct? Now suppose instead of array, I am using a linked list. If it is a linked list, then one element will be here, one element may be here. While executing this part of the code, which is located in the main memory, and I need a data which is stored in the second part of the second page or second part of this program, what I need to do immediately, I have to move this content to the secondary memory, and this content I need to bring back to the main memory, because unless we bring this part from secondary to primary memory, you won't be able to execute. This is also known as page fault, means anything that I am looking for is not available in the main memory. It is known as occurrence of a page fault. So if I use linked list, then chances of page fault is much higher. This is considered as a very big problem with program scheduling or process scheduling, and this is carried out by the operating system.